Okay, this section of the videos is about how to actually write the sentences to describe categorical data. So at this point, I think you should know how to do a table, how you should do a graph for categorical data. So that's pie charts and bar charts and frequency tables. And so I'm going to assume that to start with. And so I'm going to use the example from the NC births data set, which is the simple random sample of 1,450 birth records taken by the North Carolina Center. And the two variables I'm going to use that are categorical are plurality, which is the number of children born of the pregnancy, which is 1, 2, or 3, a singleton birth, a twin birth, or a triplet birth, and whether or not the mother consumed alcohol during the pregnancy, which is under drinking, or drink, and it's a 0, 1 variable. 0 if they didn't, 1 if they did. Okay, so that's the example I'm going to use. You can find this data set if you want to follow along in the Minitab library that's up on Blackboard, so the class library on Blackboard. All right, so my first example has to deal with this idea of plurality. And so I'm going to show you a table that might have been generated. This happens to be an APA style table based on the Minitab data set. And so this is an example where there is no missing data. Okay, so there were 3 categories. You can see the count, you can see the percentages. The goal of writing the sentences is to make sure that you write the sentences with enough specificity and detail that someone who has never seen this table could reproduce it. Now, don't get me wrong, you have to know this table to start with. It's not like you can figure this out without doing it, but the sentences should stand alone. And so I would first of all start with a sentence that describes the study. This is an observational study of 1,450 randomly sampled birth records from North Carolina in 2001. A couple important components. We want to know if it's observational or experimental. You certainly could have added that this is a cross-sectional observational study, okay, but that's extra information. We want to know how the records or how the observational units were obtained. And so in this case, it's random sampling, which is a very important concept. And then finally, you want the sample size, so you see the 1,450 there. And then certainly the whole sentence is in context. So we're not just doing a sample of 1,450, period. It's birth records from North Carolina in 2001. So we're going to use this as kind of our opening sentence anytime we describe data coming from a study. The next set of sentences come from this idea that I want to be able to exactly replicate this table. And so you see that my first part of the sentence says 1,401 records indicated a singleton birth. And in parentheses, I put the percentage. 1 point. When you use a number at the beginning of a sentence, you have to spell it out. You cannot use the digits 1401. Okay, proper writing is to spell it out. And then finally, I add the other ones. 45 records, or 3.1%, twin birth, and 4, a triplet birth. Okay. Now, think about the fact that if all you had was this set of sentences, right, could you have created this table? Could you have sketched a bar chart for me? Could you have possibly formatted a pie chart for us? Maybe sketched it, a pie chart for it. That's the goal. Okay, so that's one example. Let me go to the next example, which has to deal with some missing data. And so the next example is about the drinking status of mothers. Okay, so you will find that if we look at the frequency table, that there were 5 records that didn't have a response. So there's 2 ways to treat that. We talked about in terms of doing both the graphs and the tables. One is to, as I'm saying here, remove the missing data from the tables and the graphs, and therefore from the percentages. And so in the graph, they show only 2 categories. The percentages add up to 100%, and that's because 5 birth records did not have information provided. Similarly, in the table, we have the count adding up to the 1,445 because the 5 birth records are didn't have a response. And once again, these percentages are out of 1445, right? They will change if we're going to make them out of 1450. So we want the table and the graph to match, and then once again, we're going to write sentences. And so notice that the first sentence is pretty much the same. Actually, it's identical because I cut and paste it, right? So observational study of 1,450 records from North Carolina in 2001. Now, I'm going to describe what I'm seeing here. So first thing I tell you right off the bat is there's 5 birth mothers that didn't answer the question. Okay, so now I'm going to tell you of the remaining 1,445, here's what happens. There are 8, or 0.6%, that reported drinking alcohol during pregnancy, and the rest of them did not. Okay, so once again, it adds to 100% because we've excluded the 5 records. I also want to point out that percentages are always, no matter if it was the example before or after, rounded to 1 decimal place. So my third example then is what happens if we want to include missing data as a category and therefore in the percentages. Okay, so once again, here's a graph, and notice now I have 3 categories. And I have the ones that didn't reply here. I don't have a footnote because they're included in the graph. Okay, and if we look at the table, they're included as a category in the table. And so now this table sums to 1,450, and these percentages sum to 1,450. But notice they've changed. Granted, slightly, because if 5 out of 1,450 isn't that big a deal, but it's important to be clear here. And so once again, this table matches this graph. So we're going to do the sentences similarly. This is an observational study, so you once again see that first sentence, right? Fine. Now I'm going to tell you 5 birth mothers didn't answer a question, 8 birth mothers reported drinking, and 1,437 reported not drinking during alcohol. So no footnote, and we're considering missing information as a valid category. Okay, so any of these techniques, right, will work on this. So let me kind of go up and make sure that I've covered my notes. You're going to make sure the graph, table, and narrative are presented the same way. So how they handle missing data. Missing data in this case is a category, and I'm going to discuss missing data in the narrative. Up here, remember when we excluded missing data, once again, we're still going to make sure that it's presented the same way. We're going to add footnotes to the graph and table and make sure that we discuss the data in the narrative. In our first example, there was no missing data, so it really didn't matter, but you do not actually need to say there's no missing data. If you're not talking about missing data, people should rightly assume that there is no missing data. So let me go up to my general notes then for this section. When we're writing sentences, the goal is to describe the study, mentioning the type of study, observational versus experimental. If you want to go further and talk about cross-sectional or a completely randomized design, those are fine. The type of sampling, whether it's random or non-random, and certainly once again you can get into the details of that, whether it's simple random sampling, stratified random sampling, and so on, and the sample size, and all of this should be discussed in context. The second one says you should discuss missing data, and particularly if it's included or excluded from the tables and graphs, and be consistent about this. Okay? Discuss each category and give the frequency, percentage, or both. I'm going to tell you that typically percent is more important than frequency, because if you're giving frequencies, people in their head are trying to calculate the percentages, so why not make it easier on them and give them the percentages? You should round all percentages to 1 decimal place, with the exception that if you're getting 0.0, then you really round to the nearest non-zero digit. So you might have to do 0.03 because that would round to 0.0, or 0.004 because once again that would round to 0.0. But if you had 0.07, that actually rounds, and so you should round it to 0.1%. You're going to use the information that you generated in the tables and graphs to write the sentences, but the sentences themselves should stand on their own. So you shouldn't have a sentence that says, as you can see in the graph, the majority of births are singleton births. No, I want enough specificity and detail so that they can exactly, so if done well, which is if you want a good grade, a reader should be able to recreate the table exactly or sketch the pie or bar chart exactly without actually seeing the graph or table, just from the way you wrote your sentences. All right, so that's how we're going to write categorical sentences. And so if you were thinking now of kind of putting it all together, if you were submitting for me an assignment on describing a categorical variable, it would look like this. I would say, this is my research problem, here's my graph, here's my table, here's my sentences. And once again, whichever format you want, a graph, table, sentences.